Welcome back, Physical Science 20. This is part 2 of the 7.2 section, Mass Relationships and Chemical Equations. So we went through that, and hopefully you had an opportunity to complete for question 1B and also try questions 2A and B. Hopefully you got the right answers. If you didn't get those answers, please come and see me, and we'll try to figure out where you may have made a mistake. And if you wanted to, you could try this next question too, number 3. You have to figure out the balanced chemical equation first and then go from there. Okay, so to wrap up, stoichiometric amounts. In the lithium hydroxide example, 40 moles of lithium hydroxide is required to absorb 20 moles of carbon dioxide. Note that these amounts are multiples of the amounts in the balanced chemical equation. So we say that they are stoichiometric amounts. A stoichiometric amount is the predicted amount of reactant relative to another reactant that will react according to the balanced chemical equation. So the balanced chemical equation is the key. For example, here, 1 mole of propane reacts with 5 moles of oxygen to produce 3 moles of CO2 and 4 moles of H2O. Those numbers there are sneaky ways of going from one substance to another, a conversion factor, a mole ratio. So they're very important. Very important to have the balanced chemical equation. And of course, when stoichiometric amounts of reactants are available, you shouldn't be left with any reactants left over. Of course, that is not true in real life, but if we were to follow if we had exactly 1 mole and exactly 5 mole, all of those reactants would be converted. Okay? So in summary, stoichiometry makes the use of relationship between mass and the amounts of reactants and products in a chemical reaction. The amount of products in a chemical reaction can be predicted from the amounts of reactants that you have. The masses cannot be predicted from the masses, though. It has to be the moles. So stoichiometry problems involve masses can be solved by converting masses to moles and using the mole ratio. Reactants are present in stoichiometric amounts if they are in the same ratio as the balanced chemical equation. Theoretically, stoichiometric amounts are completely used up in a chemical reaction. Does it happen in real life? We'll see later on that it's virtually impossible, but for right now, we'll assume that they can be. Okay, so the questions I want you to do here, number 1, 3, 5, 6, 7, 8, and 9. And I think it's pretty clear cut here. First question is a qualitative one. Why do you need a balanced chemical equation? I just mentioned that. Rewind the video. And over here, we're looking at, are these stoichiometric amounts? Are they going to be used up perfectly? If aluminum and oxygen combine in a 4 mole to 3 mole ratio, is that equivalent to saying 2 moles to 1.5 moles? So you simply say yes or no for those ones. And the rest of these are very similar to the ones we just did there. So hopefully there shouldn't be any issues with these questions. Of course, if you have any difficulty, please come and see me. Okay, we'll see you again.